Hello people, so today we'll be solving LeetCode daily question 2251, which is the number of flowers in full bloom. So what basically a question states that we be given a 2D index, zero index 2D array of flowers where flowers I will be equal to start and end, and the ith flower will be in full bloom from the start day to the end day and inclusive, and will be also given as zero index array of the people of size n, where people I would be the time when the person would be visiting the garden basically, and we have to finally result the answer that when the person visits the garden how many flowers he will be seeing in the bloom. So let's move to the test case. So okay, like let's see, we are given the array 1 6, which is okay 1, and at zeroth index we are having the array 1 comma 6. So the zeroth flower will be blooming from day 1 to day 6. Similarly, first flower will be blooming from third day to seventh day. Here, third day to seventh day. Similarly, third flower will be blooming from ninth day to 12th day, and third flower will be blooming from fourth day up to 13th day. Okay, so and we are also having a people array. So if a person visits on second day, we can see only one flower is blooming. So in the output we have one. In when the person visits on third day, we are having two flowers are blooming. Similarly, on seventh day, when the person visits, we are having two flowers blooming, and similarly on the 11th day, when the person visits, we are having two flowers blooming again. Okay, so this is basically the question. So what we can do is we can firstly we'll be using two list chart. Okay, list start and end. So in this we'll be storing that for every index when the flower will be start blooming, and when the flower will start and when the flower will be dried down or it will not bloom. Okay, so let's add values to this, like using a for loop. uh, for I in flowers, what we'll do start dot add I0, and similarly end dot add I1 plus 1 to make it one based indexing. Okay, so after this we'll just be simpling sorting start, and similarly we'll be sorting end. Okay, so uh, and then what we'll be doing, we'll be using a simple binary search technique to tell us the number of flowers that are blooming in that particular on that particular day when the person visits it. So for that only we have sorted the list, because in binary search we need a sorted array. And okay, let's create a result array of size people. Mm, people. Okay, and then what we'll doing, we'll be using a for loop. Let's say for ind 0 to length of people array. And okay, so here what we'll be doing, let's firstly find the value uh, on which day the person will visit in. Let's call it int and person I, oh sorry, people I, and let's perform a binary search, like when the flower will be blooming. So for that, let's call a function, let's call it binary search, and I'll be declaring the function in a short period of time. Here we'll be passing the array start and people array. Oh no, I'll just be passing the day. Okay, and similarly I'll be having j and binary search again, and this time I will be passing the end day and the day when the person visits, and at the answer variable, answer ind, will be just simply storing I minus j. Okay, so and at the end we'll be returning result. Okay, it's result, not answer variable, answer array, yeah, result. Okay, so this is what, how we'll be approaching the question. And let's write the binary search function. Binary search, and what we'll be having, we'll be passing the list, or let's call it, we'll be simply passing the list and the day. Okay, so similarly left equal to 0 and right will be having 2 pointers, length of list minus 1, and then while loop, left less than right, and we'll be finding the mid would be equal to left plus right by 2, right by 2, and we'll checking if day is less than list dot mid, okay, list dot get mid. What we'll be doing, we'll be moving right to the mid, or okay, yeah, here, or else what we'll be doing, that if the target is greater than the if day is greater than the mid, then what we'll be doing, we'll be simply moving left equal to mid plus 1. Okay, and simply we'll be returning the left pointer. Okay, now let's do a dry run for this. So firstly, in the list, what we'll be adding, we'll be adding, it would be a list start would be equal to 1 3 9 and 4, 1 3 9 and 4, and if I just sort this, sort start, it will look like 1 3 4 and 9. And similarly, okay, I'm writing end list sorted directly, it would be 6 7 12 13. Okay, 6 7 12 and 13. Okay, so till now it's much be clear, and now we'll be moving, okay, no, it should increment also, so it should be 7 8 13 and 14 should be here, because here we incremented 1 also. Okay, so after, up to this point, this would be how the list would look. Okay, so now let's move to the end for loop. I and equal to 0 to length of people, okay, to length of people array, let's have it, and day variable, here people 0, which is at day 2, and what we'll be doing, we'll be having a variable I, and we'll be performing the binary search. Okay, so here in the binary search, okay, let me make a new window. Okay, so yeah, here let me copy this binary search. Okay, and this also. Okay, and people array, this. Okay, so I guess this is everything we need. Yeah, and so here, okay, I variable would be binary search. We'll be applying the binary search function with start array and day, where day would be equal to 2. And now let's do a dry run for this. In the binary search function, we are having list and day. Okay, so left would be equal to 0 and right would be equal to the size of start is 4, and so it would be pointed at 3. And then while loop left is less than 3, left is less than right basically, okay, not 3, right. And here mid would be equal to 0 plus 3 by 2, that would give me 1. Okay, so then if condition, if day that is 2 basically, if day that is 2 is less than list mid. Okay, let me write the list here also. The list is 1349. Okay, so to avoid any confusion, start will be equal to this. Okay, so this is the list, and mid of list mid is 3. Okay, so yes, as we can see that 2 is less than 3, so it satisfies the if condition. And what we'll be doing, we'll be moving right equal to mid, that is 1. Okay, so else condition will not be executed. So what we'll simply put a cross over there, this is not x, this basically this is a cross. And then again we'll be entering the while loop now, while again left less than right. Okay, so now left would be equal to 0 and right would be equal to 1. Okay, so now simply mid would be equal to 0 plus 1 by 2. That would give me output as 0, because 0 plus 1 is 1 and 1 by 2 is 0.5, so basically 0. And we'll be checking that if condition, if day that is 2 is less than list mid, that is 1, because at the 0 index we are having 1. So the if condition will not be executed, this will not be executed. We'll be moving to the else condition, else left would be equal to mid plus 1. Okay, so after this left would be equal to as we have calculated mid 0 1, so at this point left would not be less than right, so this condition will not be executed. And what we'll be getting, we'll be just simply getting 1 here. We'll be after this we'll be returning left, and our left would be equal to 1. Similarly, we'll be if we do the same dry run for the finding the ending index, we'll be simply getting a 0, because we'll be having the array different. So this would how the code would work. And now let's move to the coding window, and let's declare a list of integer. Okay, let me do it like this. List of integer, it's called start and end. I'll change afterwards. Array list, so here it should be end. And then what we'll be doing, we'll be running a for each loop. Let's call it n flowers. So we'll be just doing start dot add start dot add I0 and end dot add I1 plus 1 basically. Sample over here. And after this for loop, we'll be just using the sort function collections dot sort start and okay collections sort start and collections dot sort and okay. So and now we'll be having a result array result which would be equal to and the size of people, that is people dot length. And now we'll be calculating for the value for each result index. So we'll be using let's call it a variable int equal to 0, I'll int less than people dot length and int plus plus. So let's have a variable at which day the person is visiting, people int, and let's use a variable I equal to binary search function. Here we'll be passing parameters as start and day. Okay, so similarly j would be equal to binary search end comma day. Okay, here it should be binary search end comma day, and for the result int we'll just be putting I minus j, and after that we'll be returning result. Okay. So let's have a private method binary search and this will be passing a list of integer. Let's call it list only, and we'll be passing a day variable and that at which day the person is visiting. So we'll be having two pointers, left will be pointing to 0 and right would be equal to list dot size minus 1, and while left is less than right, what we'll be calculating mid should be equal to left plus. I use this way to avoid the overflow condition, right plus left minus 2. So now if day is less than list dot get mid, what we'll be doing right should be equal to mid, else we'll be moving left equal to mid plus 1. Okay, and at the end we'll be returning left. So I guess this should work. Okay, it's giving me an error for the last index. Let me check once again. Here, list size. Oh, okay. So here the issue was in this. Here we'll not be using the last pointer. We'll be using the right pointer as the size of the list. And if I try to submit this, yeah, it works fine. So this was it for today. Thank you for watching.